In this lab, we will be using the weather dataset that has weather data for 66 different airports in the USA for April to October 2019. We will cluster the dataset into 5 distinct clusters based on key weather metrics such as visibility, temperature, dew point, wind speed, and etc. The goal is to group the airports with similar weather conditions. We will do all of this from the Azure Machine Learning Designer without writing a single line of code. Let's begin. So for this example, you were asked to create a new pipeline, but I'm going to go ahead and open a run that completed a little earlier over here. So once you get to your canvas, the first thing you'll have to do is set up your compute target. And I have done this over here. I used a compute that I already created earlier. And once I've completed that, I could close this. So now we're looking at the canvas once it's completed, but I'll just walk you through the steps of what you probably did in this lab. So the first thing you had to do is pull in the weather data set, and you could have got this from the Datasets tab over here, and you would find it all the way at the end under the samples. Once you have your data set, you would have had to pull up the select columns in the data set from data transformations. And what we do over here is we connect the weather data set to this module. After that, we had to pull in the normalized data module. And once we had that set up, we pulled in our k-mean clustering algorithm, and we've pulled this from the machine learning algorithms tool, and also the train clustering model from the model training tab over here. So note over here how we use a k-mean clustering as the first input for the train clustering model, and the normalized data as second input over here. Once we have all of that set up, we can go ahead and pull in the assign data to clusters from the model scoring and evaluation tab over here. And we're going to use the train clustering model as our first input over here, and the normalized data as the second input. Once we have all this set up, we could have clicked run, and this is exactly what your experiment will look like. So I'm going to go ahead and look at the assigned data to clusters, and let's evaluate this model and see how it actually performed. So I'm going to go over to outputs and logs. So now we're going to go ahead and visualize our actual run. So I'm going to go ahead and scroll over until we find assignments, and I'm going to click on that over here. So from the results, you can observe that each row, the input in the data set, is assigned to one of the 5 clusters, 0, 1, 2, 3, or 4. You can also see for each input how far that input was from the various centroids. The cluster assignment is made based on the shortest distance between the input and cluster centroids. From the bar graph, you can see the frequency distribution for all the inputs across the 5 clusters. And that brings us to the end of this lab.